In Lesson 9.1, we'll learn how to secure a Linux system. We'll start by taking a pessimist's perspective on security, because that's really the best perspective to have when you're a security person, is to really be pessimistic about everything that somebody's trying to do on the network. Assume the worst, and in this way you'll be prepared for the worst. So the question to ask yourself is, how paranoid are you? Because when it comes to security, it's not if an attack happens, it's when it will happen, because any system attached to the network nearly always gets attacked. Certainly any system attached to a public network will come under close scrutiny and will be attempted for exploit by attackers. A few years ago, there's all sorts of statistics out there, of course, but you could attach a Windows 95 computer to a public network and it would be hacked by somebody with a bot network, for instance, within just a few minutes. 2 to 3 minutes it would be hacked and owned on the network. Linux statistics are a little better, mostly because they have a smaller footprint on the network, but they absolutely are just as vulnerable to attacks. So what are some of the most common attack vectors? Here's a few of them in no particular order, really. One is software bugs. This is probably the most common vector for attack. A software bug can come in a lot of forms. It could be a bug in web server software. It could be a bug in the kernel, the Linux kernel itself, and how it listens on the network. It could be a bug in your own software running on the web. So no matter what that interface is, software is malleable and buggy and is the most common vector for attack, various bugs in software. Social engineering is another source of attacks. So that means that somebody calls you up and convinces you to change the password for another user. If you were convinced, then you were the subject of a social engineering attack. Another example is somebody trying to get into a secure area. They follow somebody who has credentials, who has their key card and lets themselves in, and they do what's called tailgating. They just follow right behind them through the door that was already open. That could be also considered a social engineering attack, and that's a very common way that systems end up getting hacked. It could be through compromised credentials. That might mean a number of things. It might mean that somebody guessed your password, so they're trying to log in to, say, your Google Mail or your Yahoo Mail account, and they knew your username because they knew your email address, so they just had to guess your password. And once they guessed it, they've brute forced your password and your credentials have been compromised. Or in the example of SSH, if you have a public-private key pair, if your private key is stolen, then your credentials there are also compromised. That's a very common attack vector. It could be physical theft. You could be, on an airplane and you have your laptop in the bag and your bag gets stolen. At that point, you can consider any data and possibly any credentials that were available on your laptop are stolen, and that's now compromised. That's a source of attack. Could be, in a business context, it could be a malicious insider, somebody that has been given access, trusted access to the information, but does something nefarious with it, uses that information in a way that was not expected or anticipated. That can be considered an attack vector. It could also be some third party. Some outside party who has nefarious intentions. For instance, you might consider the NSA, the federal government, to actually be an attacker because they've compromised the fundamental security of the internet. So you might need to protect against your own government in some cases. So there's a lot of things, fortunately, that you can do to improve your security. They say that in Linux or in systems in general, there's nothing that you can do to fully secure your system if it's on a network. In order for a system to be secure, it needs to be put in a metal cage to prevent electronic interference and not connected to any network. Clearly, a computer not connected to a network is not very useful, so instead we have to do some things to secure it. So here's a few of those things, and we'll demonstrate them as well. You should install patches first and foremost. The first thing I do when I attach a new Linux system to the network, or in some cases before I attach it to the network, is install patches on it. Patches fix security bugs in software. So there's been some time that goes on between the time the operating system is installed on your Linux server and the time that your Linux server is attached to the network. Maybe this is a month, maybe it's a few days, whatever it is. Some bugs have likely been discovered, and some of them may be about security. And so by patching, you go out to the internet and you download the newest versions of software and install it, and you're no longer vulnerable to those security bugs that have been found. You should also disable any unused services. So these are things that might be listening on the network on your system. By default, you install a new Linux system. It's listening on several ports. You might not be using, say, the print service that is listening on a port, so you should disable that. It reduces your footprint on the network. You should remove any unused software or any other users. In general, a minimum system is the more secure system. So if you have user accounts on the system that aren't being accessed, if nobody's using them, they should be removed. You can take a few steps to secure your TCP/IP stack. For instance, we learned about the IP forward flag. If your system doesn't need to forward TCP packets or IP packets, it should disable that feature. You can tune OpenSSH. OpenSSH is enabled by default on most Linux systems and is really a common thing for system administrators to need, but it can be tuned for better security. Obviously, you'll want to back up your system and send some logs off to a remote system. Those are a few steps we've already learned about. You should use sudo in all cases because it gives you auditability, an audit trail about who ran which command. You should also configure IP tables, which we'll learn about in some detail, to have host-based firewall to permit access to services for trusted hosts and prevent access to those services from untrusted hosts. So let's dive into some examples of securing a Linux box. So I'm logged in now to a fresh CentOS box, a new virtual machine that we haven't been using for examples so far. Like I said, the first thing that I like to do is to patch the system. And so to do that, we use the yum command. We learned about yum as the tool that we use to install new software on the system. That's how we also update software. So I can type sudo yum update. And what it does is it goes out to the internet and finds out from the yum repositories what software is available. And we can see here that there's a whole lot of software. We have a new kernel out there. There's a new bash package available. So we don't know which one of these were security updates. If we wanted to, we could investigate in detail and figure out which of these were for security and which of them are bug fixes. But in general, it makes sense to update your software on a pretty regular basis. So we're going to go ahead and just say yes, install all of these. So now Linux and yum are going out to the software repository. They're getting the package details, and they're going to install them all on this system. This is a pretty easy way to patch a Linux system, but you can imagine if you have hundreds or thousands of machines, this can be a little trickier. The other thing that's concerning or troubling about patching software is that this might be a live in-production system. It might be serving web traffic or database traffic, whatever it's doing, whatever its job is. If you update the software, it might introduce some new bug, and this is pretty common actually, where it's up and running and live and everybody's happy, and you run a patch and suddenly it stops working. So you often, in a large organization, you'll time patches. You'll do it for a period of low downtime, or you might even need to reboot the system if you need a new kernel install, such as in this patch. In that case, the system needs to be rebooted in order for the new kernel to start to be used. So you have to plan for system downtime, and organizations often have very careful scheduling around this sort of thing. So our patching is still running at this point. It's downloaded all the new packages from the repository, and it's installing the new versions. We can see at the moment it's installing the kernel, 2.6.32. So it's still just kind of going through its patching process. Now it's cleaning up old packages. It's kind of finishing things up. And after this, the system will be fully patched. So we can assume that any security updates that it needed have been installed. Now, of course, this doesn't mean that there won't be additional updates in the future. So you really need to plan to update your system on some regular basis. There are actually compliance objectives. For instance, PCI, the PCI security standard says that you need to install critical patches, that is, patches of critical security flaws within 30 days of them being announced. So this is something you need to get in the regular habit of doing. It's one of the things that will keep your system the most secure. Now we've finished with patching. All of the packages have been updated. It says it's complete, so we can assume that patching is done. So one question you should ask yourself, of course, is how can I trust this repository? How do I know that the software repository upstream, where on the internet, where my server went to get all of the packages from, how do I know that that repository has not been compromised? And absolutely, that is a valid question. In the past, a number of distributions have actually had compromises of their software repositories. This happened to Debian, for instance, a few years ago. So it's a valid question, and you just have to decide how paranoid are you. If you don't want to trust all of those sources, you can set up your own repository and hopefully trust your own repository. Most of us don't take that step. In a highly secure environment, you might need to, however. So the next thing we can check out is to remove unused software. So I use the rpm-qa command So what this does is query all of the available packages on the system. So this is all the software on the system and their versions. If I pipe this output to WC-L, this is giving me a line count. WC-L does a line count. So we take all of this output and we give it as input to word count. And so it's telling me there are 276 packages installed on this system, which is really not a huge number. This is sort of a minimal system. But I bet if we look hard, we can still find some things we don't need. For instance, one risky thing on a server is to have a compiler. This is something that's just common sense to remove. On a production system that doesn't need to compile software, you can often get away with not having a compiler because an attacker could upload source code and compile it locally and not need to go out to the internet to download any of his hacking tools. So in order to remove it, I like to use sudo yum erase, and then I'll give it the package name. This is the C++ compiler on the system, gcc-c++. And it asks me, am I sure I want to remove it? And I say yes. So now I've reduced the footprint on my system a little bit. I have less software. That's less of a footprint for an attacker to use for nefarious purposes. Another thing to check out is installed kernel modules. So I can type sudo lsmod, and it shows me all of the kernel modules on the system. I might not need all of these modules. In fact, I almost certainly don't. For instance, I've got a few of them highlighted here. These are parallel port drivers. So if you have a printer and you have some old system with a parallel port attached to it, you would print over the parallel port. I almost certainly don't need a parallel port. Unless you're a Linux print server with a parallel printer, you won't need it either. So we can turn those off. And the way I do that is in the etc modprobe.d blacklist.conf. This is where I can blacklist any drivers I don't want to use. So I've just used Shift-G in VI to get to the end of the file, and I'm going to blacklist those drivers that I saw. That was parport and ppdev, and I'll copy and paste, and I'll change this word to parport PC. So here's the 3 drivers I had highlighted. And so the next time this system boots up, these 3 won't be loaded. If I wanted to remove them without rebooting, I could say rmmod ppdev, and I could say parport PC. I could just do the same thing I did in the blacklist.conf. And now if I do sudo lsmod, I don't see them in any of this output anymore. They've been removed, and we know that since we put them in the blacklist.conf, they won't come back after reboot. So just another way to reduce the footprint of the server. We can also remove unnecessary users on the system. So if I look at the etc passwd file, there's a whole lot of users in here. I don't really know what they all do. I know that I don't need some of them. Like I don't really need the games user or the gopher user. I might not need, for instance, the shutdown user. So I could say sudo userdel gopher and sudo userdel games. And so we're just reducing the number of available users. Now, this isn't adding a ton of security. These are little things. The games user and the gopher user we can see here, they had a shell of no login. So you couldn't even use those user accounts anyway, and they didn't have a password set. But we're just talking about reducing the system to the bare essentials in order to operate. So another really important step is to reduce the number of services the system is using. If I use our favorite netstat command, -tnlp, and I'll use sudo for this, we can see that this system is listening on SSH, it's listening on port 111 and port 51337. We can see what service these are listening on. On the right side here, we have RPC bind. We know that port 22 is SSH. We probably don't need all of these ports open. So what I like to do is to just turn off anything I know I'm not going to need. I do know that I'm going to need SSH, so I'm going to leave that one running. But I'll go ahead and look at PS output, and I'll search for 1076. And I can see here's the RPC bind service. Services are started and stopped, as we learned, under etc init.d. And if I list this, there's a whole bunch of output, one of which is RPC bind. So I can say sudo service RPC bind stop, and that will stop that service. And now if I look at my netstat output again, I don't see RPC bind in the output anymore. So this is stopping it for this session, but I really need it to be off permanently. After a reboot, say I patched my system and I rebooted, right now that service will come back on. I want it to be turned off permanently, and so in order to do that I use the check config, chk config, and I say rpc bind off. Now I know it's not going to come back up, and I can investigate it by check config -- list rpc bind. We can see it's off at every run level. Think back to when we learned about run levels. Those are different stages of the system boot process. Right now they're all turned off. So we know this isn't going to come back after a reboot. Now some of this is just some knowledge you gain over time. For instance, I know that the rpc.statd service, this is another listening port on 51337. This is the NFS lock service. So I'm going to also say service NFS lock stop. And I might also say service check config NFS lock off, so it doesn't come back after a reboot. Now let's look at our netstat output. I used my reverse search. I used Control-R and typed in net, and it brought up my last netstat command. Now we see I only have SSH listening. So at this point, we've significantly reduced our network footprint. You have to think about any listening port is sort of like, imagine a house, and the house has windows and doors, and when your house is getting attacked, an attacker could pick any of those windows and doors to come through. Any one of them is a vulnerability or a weakness. And the same thing is true of ports. So we want to reduce the number of available ports, so just to reduce the footprint that an attacker has to try to compromise. So we've turned off a bunch of services, we've removed some unnecessary software, we've removed some kernel modules we didn't need and some users, and most importantly, we've patched our system. At this point, we've taken some steps to improve our security posture. If you needed to learn more, and you almost certainly do, to properly secure your system, here's a few different resources you can turn to. The Red Hat Enterprise Linux Security Guide, you can Google that, or you can look at the link I've posted. Ubuntu has some really nice security steps as well. All the security steps are similar but slightly different between distributions, so you'll want to take the steps appropriate for your distribution of choice. And to keep up on current Linux security trends or to communicate with other Linux users on forums, use linuxsecurity.com as a great resource.